We will now solve more problems. An object initially at x equal to 5 meter moves to x equal to 15 meter in 10 seconds. What is the average velocity of the object during this time? What is the average speed during this time? You recall the difference between average velocity and average speed. Well, this time the motion is along a straight line and not along a curve. So always start by picking the given data. The initial position x1 equal to 5 meter, the final position x2 equal to 15 meter, and this change in position occurred during a time interval delta t equal to 10 seconds. So what is delta x, the change in position? Delta x is x2 minus x1, which is 15 minus 5, that is 10 meter. And this delta x happened during this delta t equal to 10 seconds. Therefore, average velocity is delta x divided by delta t, which is 10 meter divided by 10 seconds, 1 meter per second in the positive x direction. You can see the velocity is positive. That means the object is moving to the right with a velocity of 1 meter per second. It means every second its position changes by 1 meter in the positive x direction. That's the meaning of this velocity. Now, since the motion is along a straight line, the distance covered s also equal to 10 meter. That means the average speed is distance covered divided by the time taken, which is also 1 meter per second. But what's the difference here? When you describe speed, you are only interested in the rate at which the distance is being covered. You are not interested in the direction. So look at the way we write the speed and the velocity. The velocity is 1 meter per second in the positive x direction, whereas speed is 1 meter per second. Velocity has a value and a direction, whereas speed has no direction. Now, a quantity that has only a certain value and has no direction is called a scalar quantity, whereas a physical quantity that is understood only by the description of how much and also in what direction is called a vector quantity. So physical quantities can be separated as vector quantities and scalar quantities. Now, lesson 3 we will use completely for the study of vector quantities. Okay, let's do another problem. A jogger starts from a point A at x equal to 4 meter and jogs until he reaches the point B equal to at x equal to negative 154 meter in 1.2 minutes. He then jogs back and stops at point C at x equal to negative 120 meter in another 20 seconds. Find the jogger's average speed and average velocity, one in going from A to B and in going from A to C. Well, can you do that on your own? The jogger starts at point A. Point A is x equal to 4 meter. Now this is x equal to 0, so he starts on the right of the origin and goes to the left. And point B is x equal to negative 154 meter. What is the distance delta S covered by the jogger? His initial position is x1 equal to 4, x2 equal to negative 154. Look at the distance he's covered. He covered from 4 meter to 0, that is 4 meter, and from 0 to negative 154 is 154. What is the total distance he covered? It will be 154 plus 4, which is 158 meter. That is the distance he covered. Now, what is the time taken to do that? He did that in 1.2 minutes. 1.2 minutes is 72 seconds. So, delta S is 158 minutes. Delta T is 72 seconds. The average speed is delta S divided by delta T. And that will be 158 meter divided by 72 seconds. That is 2.19 meter per second. That is his average speed in going from A to B. Now let's find the average velocity. In order to find the average velocity, we need the displacement. And watch how we obtain the displacement. Displacement is final position minus the initial position. That is the definition of displacement. Change in position. Final position minus the initial position. What is the final position? Negative 154 minus the initial position, minus 4, and that is negative 158 meter. I want you to understand the difference between distance and displacement. Distance is 158 meter. We are not interested in the direction. Whereas displacement takes place in a specific direction. Displacement is a vector quantity. It has a magnitude, that is the value, and also it has got a direction. Therefore, the average velocity is delta x divided by delta t. That is negative 158 meter divided by 72 seconds. That is negative 2.19 meter per second. What is the difference between the average speed and the average velocity? The average speed tells you that every second the object moves 2.19 meter. Average velocity tells you every second the object, the runner, it's not the object here, the jogger, every second the jogger changes his position by 2.19 meter in the negative x direction. You see, this has two information, whereas the speed contains only one information. Alright, let's now do the second part. What are the average speed and average velocities in going from A to C? What is C? This is C. The jogger started from A, he moved to B, and then he moved to C. C is x3 equal to negative 122 meter. Now what is the total distance traveled by the jogger? The total distance is from A to B is 158 meter. Then B to C is the difference between these two, 154 minus 122. So the total distance is traveled is 158 plus 154 minus 122. He traveled 190 meters. What is the time taken to do that? It took 1.2 minutes to move from A to B, another 20 seconds to go from B to C. So what is the total time? It is 72 seconds plus 20 seconds. That is 92 seconds is the total time. And therefore average speed is 190 meter divided by 92 seconds is 2.07 meter per second. But now watch. What is the displacement of the jogger? The jogger got displaced from A to C. What is the displacement? Delta x is final position minus the initial position. Negative 122 minus 4, that is negative 126 meter. Alright, and this displacement occurred during the same time, 92 seconds. What is the average velocity? Average velocity is the rate at which the displacement occurred. That is negative 126 meter divided by 92 seconds. That is negative 1.37 meter per second. Now tell me, when the jogger reaches back to A, what will be his displacement at that time? He started from A, jogged to B, reached to C, and then back at A. What will be his displacement at that time? The displacement is 0, because the change in position is 0. So what will be the average velocity during that trip? The average velocity is 0. Does it mean that the average speed is 0? No. The average speed will not be 0, but the average velocity is 0. Why? Because the velocity while going from A to B is negative. The velocity while going from B to A is positive. So the average velocity will be 0. Alright, let's do another problem. A plot of position versus time of a moving object is shown in the diagram here. I hope you can see all that diagram. What are the average velocities for the segments AB, BC, CD, DE, EF, and FG? What is the instantaneous velocity at the point D? Well, you know that if the position against time is a straight line, the average velocity will be the slope of that graph. So the average velocity for the segment AB is the slope of the line AB. Average velocity is the slope of the position graph against time. And therefore, for segment AB, what is the slope? Can you tell me what is the slope of this line AB? AB will be delta x divided by delta t. You notice that delta x is the vertical line, delta t is the horizontal line. What is that delta x? Delta x is 2 minus 0, that is 2, and delta t is 1. If you notice, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the x position goes 0, 1, 2, 3, 4, 5, 6, 7. Alright, so delta x is 2 meter. Delta t is 1 second. The average velocity for that segment AB will be 2 meter per second. How about segment BC? Segment BC is horizontal. Tell me, what is the slope of a horizontal line? It is 0. What does that mean? It means during this time that object is at rest. In fact, if that object is a person, he got into McDonald's for a coffee during that time, he is resting. There is no velocity, there is no change in position during that time. Therefore, the average velocity is 0. There you are. How about for segment CD? Alright, what is delta x? Delta x will be 4 minus 2, that is 2 meter. Delta t is, you see that, this is 3.5 minus 2, that is 1.5. 2 meter, that is delta x. Delta t is 1.5 second. That will be 1.3 meter per second is the average velocity for that segment CD. Alright, how about the segment DE? Well, I want you to look here carefully. What is delta x? Remember, delta x is final position minus the initial position. What is the final position here? The final position is negative 1.5. What is the initial position? 4 meter. So that will be final position is negative 1.5 minus the initial position is 4. Negative 1.5 minus 4 is the change in position delta x. Delta t is 6.5. This is 6 seconds. This is 6.5 minus 3.5. Alright, and that will be negative 5.5 meter divided by 3 seconds. That is negative 1.83 meter per second. Notice here that the velocity is negative during that time. How about the segment EF? Again, EF is horizontal. The slope of a horizontal line is 0. The average velocity there is 0. Alright, how about FG? For the segment FG, can you tell me what is the change in position? The final position is 0. The initial position is negative 1.5. Therefore, what is delta x? It will be 0 minus negative 1.5. Is that right? Final position minus the initial position. That is 0 minus negative 1.5, which will be 1.5 meter. And the time interval is 1.5. And that is 1 meter per second is the average velocity during that time. Well, this kind of simple problems you must be very familiar with. Alright? Alright, read this problem and see what information we have. The position of a certain particle depends on time according to x of t equal to 1 meter per second squared t squared minus 5 meter per second t plus 1 meter. Find the displacement and the average velocity during the time interval 3 seconds less than or equal to t less than or equal to 4. Alright, let's do that part. What does that mean? Find the average velocity during the time interval from 3 seconds to 4 seconds. What is the time interval there? The time interval is just 1 second. Alright, what we need to do is we need to know the position. Now, what is the value of x at 3 seconds? Then what is the value of x at 4 seconds, so that we can find the change in position during that time interval. So if x of t equal to 1 meter per second squared t squared minus 5 meter per second t plus 1 meter, then x of 4, what does x of 4 mean? The position at time is 4 seconds. What all we need to do is replace your t by 4. And what does that give you? It will give you negative 3 meter. That means at t equal to 4 seconds, the object is, the particle is at negative 3 meter. Similarly, let's find the position at x equal to 3, at t equal to 3 seconds. X of 3, replace t in this equation by 3. And what is that? I want you to do this calculation on your own. Now, check whether you can get negative 5 meter there. Alright, in that case, what is the change in position? At t equal to 3 seconds, the particle is at negative 5 meter. At t equal to 4 seconds, the particle is at negative 3 meter. What is the change in position? Tell me, is the change in position positive or negative? What do you think? Alright, let's do that. Displacement is x of 4 minus x of 3. Final position minus initial position. That is negative 3 minus negative 5. That is 2 meter. So the object moved from x equal to negative 5 to x equal to negative 3 in the positive x direction. That is the displacement. And this displacement happened during what time interval? The time interval is 4 seconds minus 3 seconds. So average velocity is x of 4 minus x of 3. That is the displacement, delta x, divided by delta t. That will be 2 meter divided by 1 second. That is 2 meter per second. That is the average velocity during that interval. Okay. A ball is thrown up from a point A at y equal to 0. The ball reaches the point B at y equal to 20 meter in 1.4 seconds, where it stops and falls back to the point A. Assume that the time taken by the ball to move from A to B is the same as the time taken to fall from B to A. Is that true? If I throw something up, is the time taken to go up equal to the time taken to come down? Actually, it is true. We will be looking at that as we go on. The time taken for an object to go up is the time taken to come down. Alright, what is the first thing we need to find? What is the displacement of the ball from A to B? Well, A is y equal to 0. B is y equal to 20. So what is the displacement? For the upward journey, y1 equal to 0 and y2 equal to 20. You notice here that because the motion is vertical, in place of x, we are now using y for the position function. Therefore, displacement delta y is final position y2 minus initial position y1. 20 minus 0, that is 20 meter. What is the average velocity of the ball from A to B? Average velocity is displacement divided by the time. What is the time taken to do this displacement? Is 1.4 seconds. Therefore, V average is delta y divided by delta t. That is 20 meter divided by that 1.4 seconds. That is 14.3 meter per second. This is for the upward journey of the ball. Alright, let's now consider the downward journey. The ball is going to move from point B to point A. The displacement of the ball from B to A. Well, y1 for this journey is 20, that's the initial position, and it comes back to its final position, y2 equal to 0. Displacement is, what's the definition of displacement? Final position minus the initial position. That will be 0 minus 20 is negative 20 meter. Watch that again. For the upward journey, the displacement is positive. For the downward journey, the displacement is negative. What is the average velocity for that downward journey? That will be displacement divided by the time, which is negative 14.3 meter per second. Watch here. The upward displacement is 20 meter. The downward displacement is negative 20 meter. What is the displacement, total displacement for the entire journey? Total displacement is 0. Alright? The average velocity while going up is positive 14.3 meter per second. And the average velocity while coming down is negative 14.3 meter per second. What is the average velocity for the entire trip? Is 0. The displacement for the entire trip is 0. The velocity, average velocity for the entire trip is 0. Alright? We answered that already. The displacement for the entire trip is 0. And the average velocity for the entire trip also is 0. Okay. How about the next one? What is the total distance traveled for the entire trip? What is the distance traveled for the entire trip? The distance traveled upward is 20 meter. Distance traveled downward is 20 meter. So the total distance traveled will be 20 plus 20, that is 40 meter. And what is the time taken for that to happen? It will be 1.4 seconds to go up, 1.4 seconds to come down. Therefore, the average speed for the entire trip is, the total time is 2.8 seconds. The average speed is distance, the total distance divided by the time, that is 40 meter divided by 2.8 seconds, and that is 14.3 meter per second. Watch here, the average velocity for the entire trip is 0, whereas the average speed is not 0. The average speed is 14.3 meter per second. How do you interpret it? For the entire journey, the object covered a distance of 14.3 meter every second. Whereas for the entire trip, the change in position is 0. It started at point A and it came back at point A. The displacement is 0, therefore the velocity also is 0. Alright, let's look at another problem. The figure shows the position of a particle versus time. On the vertical axis, I have the position x in meters, and the horizontal axis, I have the time in seconds. For the time find the average velocities for the time interval indicated A. The time interval A, what is that time interval? Look at the time on the axis. 0, 2, 4, 6, 8, 10, 12, 14. So what is the time interval indicated by A? It is 4 seconds. The time interval B is 6. This will be 7. 7 minus 4, that is 3 seconds. Now, we need to find the average velocities for each of these intervals, A, B, C, and D. Okay? Alright, let's start with the time interval A. Time interval A, if you look at this, for that time interval A, the initial position is 3 meter. If you watch here, the green line is 0. 0, 1, 2, 3, 4, 5, 6. The initial position is 3 meter. The final position also is 3 meter. And the time interval is 4 minus 0. So what is the displacement for that time interval? The initial position and the final positions are the same. The displacement is 0. And the time interval is t equal to 4 seconds. Therefore, average velocity is delta x divided by delta t, that is 0. Because the displacement is 0, the average velocity for that time interval is 0. Alright, let's go to the time interval B. Tell me, what is the initial position? The initial position is x equal to 3 meter. What is the final position for that time interval? Here, the time interval, the final position is x equal to 4 meter. So, that means delta x is 4 meter minus 3 meter, that is 1 meter. For that time interval B, the change in position is 1 meter. What is the change in time? T1 is 4 seconds, is that right? This is T1. And T2 is 7 seconds. Therefore, delta T is 3 seconds. The average velocity during that interval will be delta x divided by delta t. That is 1 meter divided by 3 seconds. That is 1/3 meter per second is the average velocity for the time interval given by B. Alright, let's go to C. Can you do that on your own? For the time interval C, what is the initial position? The initial position is x equal to 4. The final position is x equal to -2. You see that? Ignore that little bump. That is caused by my moving of the mouse. It creates a little bump there. Alright, so x1 equal to 4 meter. x2 equal to -2 meter. What is the displacement? What is the change in position? Is the final position minus the initial position. -2 meter minus 4 meter, that is -6 meter. And what is the time interval? T1 is 7 seconds. T2 is 11 seconds or 10 seconds. Yeah, this is 10. So delta T is 10 minus 7, that is 3 seconds. Therefore, average velocity is delta x, that is -6 meter, divided by delta t, that is 3 seconds. And the average velocity during that interval is -2 meter per second. Okay. What about interval D? Interval D, the initial position is -2 meter. The final position is 1 meter. Is that right? Yes. x1 is -2 meter. x2 is 1 meter. And that means the change in position delta x is initial position, final position 1 meter minus initial position -2 meter, and that will be 3 meter. And what is the time interval? The initial time is 10 seconds. The final time is 13 seconds. Is that right? This is 13, that is 14. So T1 is 10 seconds, T2 is 13 seconds, therefore delta T is 3 seconds. The average velocity is delta x divided by delta t. 3 meter divided by 3 seconds, that is 1 meter per second. That is the average velocity during that interval. Well, what I have done here is to solve some representative problems for you. And now this is the time you got to go and do all the given homework. Alright? And get back to me if you need any help. I will take you to lesson 2 a little while later.